Hello, everyone. Can you hear me? All right. So let's get started. A few announcements today. Can you please mute your microphones? Just a few things that we're going to talk about today. One thing is the exam. So we need to have a midterm exam. And given that we had fall break last week, I wasn't able to talk to you guys about it. So what we're going to do is we're going to have, you knew, I'm sure, that we were going to have a midterm. So it's not going to be today, obviously. But what I'm thinking is that, let me open the website. Can you guys see the website? Is that what you're seeing right now?
Yes, we can.
Okay. So if you're looking at the website, today is October 19th. Okay. So let's just have the midterm exam on the 26th. Okay. We're going to have it. It's just going to be an hour and a half at most. It's going to be during the second half of the day. So next Monday, I guess it would start at what time? It would start at 3:30. So it would start at 3:30 and it would run, let's say, until 5. So from 3:30 to 5 p.m. on October the 26th, you will have your midterm exam, okay? So it's gonna be obviously some kind of a online, but it's gonna be, it might be like some questions and then some problems that you have to solve, okay? And it's going to be timed for just an hour and 30 minutes. So I don't expect it to be like a long take-home exam. Instead, that's what we have the lab assignments for, right? You still have the Twitter assignment, which will be like a second, it'll be similar to the previous one, right? The RSS and HTML, but with Twitter. So hopefully, today we're going to talk about that homework, and then you'll have a little bit more, now that you've had some practice on that homework, you'll have more questions, and we can further refine that a little bit so that you can do that Twitter assignment. So anyway, the first thing I wanted to mention that's really important is that we have our exam, our midterm exam, on October 26th, okay? So that's really important. All right, so the exam will cover everything, obviously. All right, so let me switch over to so now I've switched over to Brightspace, so you should be seeing that. All right, so I'm gonna scroll down in Brightspace just to kind of go over. So as you know, we've gone over all these topics, intro, Weka, you know how to do that. We talked about some of the theory.
Professor, so is the exams going to cover like all the topics we have covered so far, or is going to be specific topics that we can cover?
It's everything that we've covered so far.
All right.
All right. So we've gone over performance metrics, data sets, and features. We still need to spend some time on this. I've graded your homework assignments. If you haven't done so already, please take a look at the homework assignment, data scraping and VSM. So we'll talk, vector space model. We'll talk a little bit about, or a lot actually, about it today. I kind of want to talk with you guys. As I said, this is one of the most essential things that you really need to understand about machine learning, right? The features. And so we need to talk about that. All right, you've had your data scraping homework. You have your sklearn homework, which is due today. This should not be difficult, given that it's just using the code that I gave you, and I've already given you the data sets. But that's due tonight. And then, as I said, the Twitter assignment, this one I will assign soon. probably the day of the exam, after the exam, you can start working on this Twitter one. And it'll be just, as I said, very similar to this one. But I want to make sure that you understand the basic concept, in particular, of the vector space model. Remember, whenever you do these things, guys, can you mute your microphones, please? So whenever we do this, these types of things, I'm always looking for you to create a data set. So if you go back to the data scraping, I want to emphasize that homework. You can see here. Okay. Yeah. All right, so with the, you can see here in part 2, with the collected data from part 1, create a corpus. All right. All right, so as I was saying, so if you look at this problem, actually, it has a lot of very important terminology. The terms that you really, really, really need to understand, that you really need to be clear on is, create a corpus. So you need to understand what that means, a corpus of annotated data. You need to understand what annotated data is. For supervised machine learning, that means something. And then you need to identify what are the samples. That's very critical. What are the features? Then you need to assign labels, right? So you need to assign these manually. And then you convert your data to the vector space model and analyze using some machine learning tool. So far, you're looking at at any machine learning tool for now. The easiest one is Weka to use, and that's why we've been using it, because the focus has not been so much on the machine learning algorithms, but instead on just the data set, the corpus, and all of that. And then what you know is once you've done it correctly and it works in Weka, it'll work everywhere else. And that's really the critical thing to understand there. And then I gave you some code, the count vectorizer, which I described in class to convert the text features. Right, so that was the homework. Pretty much everyone did really well on part 1. If you didn't do well, it's because I said, that you didn't clean the data enough. I basically looked at the graphs and I was just making sure that by looking at the graph, I could get some meaning out of it. Now for part 2, this is where I wanted to emphasize, as I said, which is really the important thing. So whenever I say create a corpus, what that means is create a data set, okay? It means create a data set of something, all right? Annotated means that because it's supervised learning, it has to have labels. So, when you see a tweet or an RSS feed or a sentence, you're going to read it and you're going to analyze it. So for instance, if you're looking at reviews, comments on YouTube, right? You'll say, oh, this comment is positive. Oh, now I read this comment, it's negative. How do you know? Well, you're an intelligent person, right? So you understand language. And that's what machine learning will have to do later, is it'll have to learn how to distinguish between these labels, okay? It'll have to learn how to distinguish between these labels, and then it's gonna learn correlations between the features and the labels, okay? So I will go over this again today. I'll talk about the mistakes I noticed in your homework assignments, and then how to correct them, because I really want you to do the Twitter homework better, right? So I want to see that better. So half of you did a great job, and then half of you.
Professor, I just want to request, like, if you could, show the small example of how to create a corpus, that'll be a lot helpful, because that is the only thing like most people find difficult.
Yeah, I'll do that.
Well, someone need to mute their thing. I can't hear anything.
Yeah, I can say who. Yeah, who is? Okay. Yeah, no, that's what I'm going to do today. So if you notice, I didn't take off that many points for not doing part 2 so great. But as I said, you know, that's why I have 2 homework assignments that are kind of similar. Key thing, and I think you'll see all the pieces are there, is just as somebody said, I think right now the word corpus probably doesn't have the specific meaning that it should have for you. Okay, so we'll, and in the fact that we're doing this supervised learning. Okay, so once we're done with this, and once I think that you guys have mastered this, I will tell you. You know, I'll look at the homework, and then we will be ready to move into the second phase of the course, which is going to be you know, machine learning, the more advanced machine learning algorithms. So today, during the second half, I'm hoping to get started with TensorFlow. So if you notice, I did not spend that much time. sklearn is great, and it used to be that it was more the tool to use, but over the years, Google has developed TensorFlow so well that it's basically like everything that NumPy can do, TensorFlow can do. Anything that sklearn can do, TensorFlow can do. Plus, TensorFlow can do all the other things, so it just makes sense to kind of go with, and the other thing is TensorFlow used to be harder, right? And they've made it easier. So they've made it, you know, they've tried to make it a lot like sklearn and NumPy. And so given that, you know, things have just changed. So you know, things will always change like that. And so one of the things we have to do, honestly, so I don't, how can I say this? So there are the machine learning algorithms. I could write pseudocode. I could just take a, you know, a pencil and kind of, or a marker and kind of draw it out on a board and just, hey, here's the pseudocode. Here's the algorithm. But then there's also programming that for parallel computing. So it's basically like there's 2 things in machine learning. There's the learning how to program, which is not, you know, everything that you've learned about programming is still there, object-oriented programming, all those great things that you've learned, but you have to more seriously apply them in machine learning, okay? So for instance, TensorFlow is very highly object-oriented now. But the graph, the computational graph, which is the underlying thing, is not. And so it's got this weirdness about how you do things, okay? And so I want to stress that, guys, that, you know, this class, usually in 530, which is the deep learning class, I go into the algorithms. But here, I will only show how to use algorithms, not so much describe the algorithms themselves. And really, I'm going to have to focus a lot of the attention to just learning how to program for machine learning, okay? So a lot of these things, and we'll do a lot of examples. So as I said, the second half of this class is very hands-on, so I'll just code, and all the code I do is always on my GitHub, so you know, you can always get it from there, but I'm gonna describe it as I go. And we'll be using machine learning algorithms. At some point, we're gonna do linear regression and all that soon, but you know, at least for the next 2-3 weeks, we'll be doing TensorFlow 2, and then also after that, I plan to do reinforcement learning. Just kind of throw that in there. You know, if you look at the again, if you look at the bright space, I've rearranged the courses a little bit again, just to kind of adapt it to how things are changing. So you can see we're kind of here. We're done with sklearn unless you have any questions about it. And then the Twitter homework, I'll assign this next Monday, not today, because I want you to study for the exam for Monday. And then we will start TensorFlow 2 hopefully today, and then Keras. And then after that, a little short introduction to the low-level API. So there's a lot of things here. TensorFlow has what is called the high-level API and the low-level API. So the high-level API is supposed to be easier to program. That's debatable, but that's how they sell it. and it's more object oriented, definitely more object oriented, and it does have some great efficiencies, and it's the latest, so it's the fastest and everything like that. A lot of bugs from 1 have been fixed, so there is that. So right now, if you want to understand things, we are taking a TensorFlow 2 high-level API approach with these lectures. When I do reinforcement learning, I kind of decided, okay, I'm going to do that in the low-level API, and so I'm going to introduce the low-level API, which is the other part of the spectrum. That's more the way that you see the inside of something. I actually like the low-level API. And then we'll introduce reinforcement learning. And then after that, I'll work in unsupervised learning. And after that, we're really done with the core things, and everything else is more like elective things. So I really do think I don't have to introduce these right away. I'll figure out how I want to approach it. But hopefully I'll spend about at least a week in reinforcement learning. I think I can do it in just 3 hours. If not, we'll spend, at most 2 days on it. But right now, the focus is going to be on this in the second half. So right now, in the first half, I wanna go over the homework assignment. And as I said, I wanna make sure that you guys are very clear on how to do the features and everything. Now, I have some more feature contents for speech and image processing. And so we will have to cover those as well. But for now, I think the easiest way to understand machine learning is to start with text. Okay, so that's what we're gonna think about. So one of the things, so let's get into the homework assignment. Okay, let's get into that. So I'm gonna switch over to the whiteboard. All right. And then please, at this point, make it, ask any questions that you might have if you're stuck. So let's think about this. So let's just focus on the homework. All right, so what did I ask you to do on the homework? On the homework, I asked you to collect HTML. It's called data scraping, right? So I asked you to collect HTML and RSS feeds, correct? Did I ask you for anything else? No, right? No. So 3 of each. Okay? And then what I said is clean it up, get rid of things. So, for instance, most of you did a great job here. Basically you do a frequency plot of the most frequent words. You'd be surprised how important it is to always grab the most frequent words. Okay, they're the ones that, because you want data that doesn't appear rarely, but instead you want data that appears a lot, but it's different for that label versus that label. So a lot of you did a great job. Obviously if you did politics, like Trump, and then it was like, GOP and Biden and, all that stuff, right? So if I see that, what is that, and I see, the histogram, everything. So I can quickly just say, oh, this graph is probably about politics, okay? That's really what I was looking for. Some of you may have had things like, 3 HTML, a period, a comma. If I saw that, you're gonna lose points, right? Because what I meant, this has no meaning, right? These are the things that I wanted you to get rid of, okay? And that was part of the whole cleaning. Remember that. Let's talk about the pipeline. So what is the pipeline of machine learning? It's not just the machine learning algorithm, right? It's not just KNN. It's a lot of it. So starts at scraping the data. Scraping data. Where would you get the data from? Images. Now the next set of examples soon, I will do image processing, okay? And you've done images already with MNIST, but they were processed for you. So, data scraping could be anything, right? So data scraping could be, like you did HTML and RSS, that's all of it is text. but it could also be images, and we're going to learn a little bit about that. I already posted some images on GitHub that we're going to download, you know, and process. It could be audio, right? Audio signals, speeches. I don't know if you're aware, you know, the NSA, they say that they, you know, they have conversations maybe, right? And they're looking for specific voices because they're, you know, they're trying to find certain people around the world, and they do it, you know, through that. It could be, you know, PCAP files. What are PCAP files? They're network data, right? It could just be network data. How is network data treated? You'd be surprised that it's treated a lot like text. You see, because it's really a, you know, what is a protocol? A protocol is a vocabulary of specific symbols and things. Okay, and you know, the list can go on. Iris was, you know, what? Just measurements. It could be sensor data. What if you have you're flying an airplane or a self-driving car? All the data is sensor data, right? And it's not always just one thing. It can be multimedia, a combination of all these things. So you could have a feature vector that has audio, images, and text all combined into one single vector. There are no rules for that. You just have to follow specific ideas, okay? So anyway, you can scrape the data. And currently, I wanted you to just focus on this one. Once you've scraped the data, you clean the data. And hopefully that was clear, you know, from this example. Then after that, usually if you're going to decide if this is supervised learning, which is the only thing we have learned so far. When I say, okay, I want you now to create a corpus. Another word for corpus is corpora. That's the plural. So what is that? It means basically a data set. Okay? A data set. But it's a data set that has been processed and is ready for machine learning. Remember what I said. What is a data set? A data set is X and Y, right? For supervised learning. So what does that mean? You have to have this terminology down, okay? Because I'm going to keep testing you on this until, you know, until the end. I want to make sure that you understand what I'm talking about. That's what 520 is really for, is just to get those, a lot of those concepts going. So what does a data set have to have, okay? Data sets needs to have certain things.
Sir, can you, yes?
Yes.
It's just one thing at a time. One thing at a time, Riyadh.
I'm going to ask you guys to please mute your microphones, okay? All right, so you have here a data set, right? That's a corpus. Now, some things that are very important here that were in the question, right? How many samples? When I say samples, what do I mean? I mean the values here, 1, 2, 3, ... n. So you have n samples, okay? When I say the features, what do I mean? I mean, so samples equal rows. Think of it that way. They represent an item, okay? When I say features, what do I mean? Feature 1, feature 2, ... feature n. I mean the columns. And the columns need to be aligned, okay? So for every sample, notice every row will have column F2. Okay? It's going to have that feature. And then what's important is the values in that feature. So for instance, let's say the values are always 1, 1, 1. But then the values over here are always 0, 0, 0, 0. What does that mean? Okay, it might mean that there's a correlation where the label might always be A, and then B, B, B. That's what machine learning is going to learn, okay? It's going to learn that whenever it sees the zeros over here, so whenever it sees these zeros, those zeros correlate with B. Whenever it sees the ones, those ones correlate with A, okay? So that's an important distinction here, okay? So that's what I want you, that's one of the main concepts that I want you to understand, okay? And so that's where you have features and you have samples. And then what are the labels? The labels are gonna be here, right? These are the labels. Every sample has a label. Every sample has a label in supervised learning, okay? Every sample has a label. All right, so let's go over here then. Oh, and let me just finish this. So then when you create the corpus, right, and the corpus has labels, it meets all of these conditions, then you're ready for, machine learning, okay? And then you have, train, test, validation, and performance, finally performance metrics. Okay, so this is the very basic pipeline, but the homework, this homework assignment was really about, I didn't really care much about this. As long as you showed me that you ran it in Weka and you did it right, I didn't care if your results were good or bad, just that you did the pipeline correctly, okay? But the thing that's key is getting this down, because a lot of the work in machine learning is going to be that you take some abstract problem and you need to create this corpus that is ready for ML. So again, remember, so the corpus then has samples, features, labels. All right, and it, so the example, the classic example that we've been using and we will continue to use is what? Iris, Fisher's Iris dataset, right? So Fisher has, again, how many features does Fisher have?
Four.
4, right? So Fisher has 4 features. Trying to get that right. All right, so it's got 4 F1. Always, whenever you get confused, think about this. That's why you stress so much. How many samples does it have? How many samples? It's got 150. You need to know this. How many labels does it have? For classes. It's got 150 samples and it's got 3 labels, right? Setosa, Virginica, and Versicolor. They're usually 0, 0, 1, 1, 1, 2, 2, 2. Okay? So how were these labels assigned? Were they magically assigned? Did they come magically from some? No, it was a person, right? So they were, this is called annotation. Or annotating, or annotate the data set. You manually put the labels in there. All right. So what are some common errors that I noticed in the homework? So one thing is, I gave you some code, right? So I gave you from sklearn, I gave you a function called count vectorizer. Okay, and I gave you the example where I gave you some sentences. Sentence, 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 sentence. These were actual sentences. Okay, and then what does count vectorizer do? Count vectorizer takes the whole set of sentences and it basically does part 1. It calculates the frequency of the words. It kind of gets the most frequent words. So just like you guys had this, Trump, whatever, all the words in here where you have the most frequent ones, right? That's the same thing that Count Vectorizer is doing. So it's going to say, you know what? Out of these are the most frequent words. It might get rid of words like the, etc., because they don't really, pretty much every sentence will have that, and it doesn't provide that much value. Okay, so Count Vectorizer does that. It creates a set of the most frequent words in the entire vocabulary. Now, we saw this in the example, right? That we had the most frequent words, and then let's imagine that I'm just going to have Count Vectorizer gives me, 5 words. 1, 2, 3, 4, 5. These are the most frequent words. So again, it's going to be like, it's politics, so Trump, Biden, what is it, GOP, voting, something else, people, I don't know. Okay, so you have 5 words. These were the most frequent words. And then after that, you have, let's say 1, 2, 3, 4, 5 sentences. Okay? Now, this is where you have to kind of define this, that your sample will be a sentence. And then you're just going to represent the sentences, though, by these words, by the occurrence of words in that corpus. So for instance, let's say that the first sentence says, Trump. Okay, so sentence 1, sample 1, Trump appears once and GOP appears 1, but none of these appear. Then you look at, again, guys, please mute your microphone. All right, so sentence 2 then might be, okay, that one actually doesn't mention Trump, but it mentions Biden, right? And so this is that, and then it mentions, voting, and then doesn't mention people. Then you have another sentence, and guess what? This one mentions, the debate or something, so it mentions Trump and Biden and people. All right, so, and so on. Do you guys understand this idea? And let's say there's another one, S4, and that one actually mentions Trump twice, probably. And then it mentions, Biden, and then nobody here. Do you see that? So what you're doing is, machine learning works like this, okay? It works in the sense that you have samples, and this is SN, and then the samples need to be represented by the features that you're using. But you really have to, it's like an encoding. You have to take the, the people voted in the election. Right? So you have that. So in our common words, they're not included, right? Because they're called stop words. You choose, they're not very helpful. Okay? So then that leaves, people. Okay, so I want to represent this sentence. So it's going to have, let's say this is S5. So people will be here as 1. And let's say voting and vote, are the same. So voting is there and the other ones are not there. This is the vector, the encoded representation of the word sentence like that. This has a name. This is called the bag of words approach. Okay. And so it's, it's a very important thing to understand, right? And right now, we're doing this with just sentences because I just want to make sure you do the homework right, especially for the Twitter. assignment, but this is the idea, okay? One thing I noticed that I think, I don't understand, some of you got confused, is that you did this not for sentences, but just for words. So some of you would do like, okay, Trump, Biden, right? And then your features were also Trump, Biden, cat, voting, car. What's the problem with this? I actually want to discuss this because there's a problem with your logic. Doing this shows that you haven't understood something important about machine learning. You might say, well, but that data set has ones too, right? This has a, and that has that, and that has, I actually don't want it to look like this. Let's see.
There's no discrepancy in the data for it to even do any learning on.
Exactly. It can't learn, exactly. So if I do, car is here, voting is over there, cat is not even there. And so this one is 0, 0, 0. This is 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. But as Drew just said, what's the problem with this? Well, and then you have the labels, right? So you have to hand annotate the label. So here, for instance, first of all, usually you would take a set of sentences and then kind of say, all right, this is a two-class problem, like with the comments, positive, negative. Politics, they're leaning Republican, leaning Democrat, that kind of thing. But here, okay, Trump, okay, sure, 1. Biden, okay, let's say 0. But what about cat? Do you have Republican cats or Democrat cats? Right? You don't know, right? Voting, that doesn't mean, car. So it doesn't really, how are you gonna figure this out like that? That's one problem, okay? That's one problem. It's not the only problem though. The other problem is, which as Drew stated, look, there's only 1, 1 in this column. There's only 1, 1 in this column. There's only 1, 1 in this column. Do you see that? There's a bit of a problem there, okay? So there's no way to find relationships, right? To find relationships in here. And so that's not really what you want. When you have a sentence, you're going to have more, more words in there, etc. And hopefully the algorithm is going to start to pick up something, some kind of a correlation, okay? Eventually, it might start to pick up, okay, whenever I see, now let's do another one. Let's do, now I have proper sentences that are from, some news, NPR, right? I saw some of you used NPR, right? And you get some political sentences, right? And then you represent them, as, now I'm going to change it a little bit to something a little bit more, more consistent. So let's say the economy, and then let's say, actually, let me change the subject. Let's say movies. Okay, so now it's ratings about movies, right? Ratings about movies. So you're gonna have, they're talking about The Matrix. Is that one cool? Thanos, I forget, the whole universe thing. Thanos, and then over here you have like, another kind of movie. James Bond, there you go, 007, and it's another action movie. The Fast and the Furious, right? So So these two types of movies are different, right? What are the two? If you were labeling these movies, and imagine these are sentences that people wrote. I thought The Matrix was really great. I thought Thanos, was great in this movie. I can't wait for James Bond to come out, right? So, but if you look at these, what are the two classes there? How would you label these? How would you label these? Nobody? Well, I would say these are action movies, right? These are action movies, whereas these are more like sci-fi or, that kind of thing. So then you have the two classes. It could be, somebody wrote something. Yeah, the genre. So yeah, I would say, -1, -1, 1, 1. There's a two-class problem, okay? You label that manually. And what I wanted you to do in the homework, which like I said, like half of you did it well, is, label them, pick a topic. So now over here, then you have to use keywords. So the keywords would be like, car chase, right? Car chase versus, amazing things. I don't know. Amazing, right? So basically the word amazing will probably appear here. But car chase most definitely will appear here. Whereas car chase, I don't know that, well, I guess the Matrix had a lot of car chases, but let's imagine it didn't. And then amazing, like sci-fi things, sci-fi, magic, things like that, aren't really in these movies. So what machine learning should do is it should pick up on this, okay? So this feature 1 versus feature 2, right? So feature 2 should discern, as Drew said, right? It finds a correlation. You know what? For F2, whenever this is not present, that correlates to a 1. Whenever this is present, it correlates to a -1. And the same goes for the car chase. Car chases correlate with 1, whereas when you don't have car chases, it correlates with -1. So eventually the algorithm gets a new movie, right? It gets a new movie, and the new movie is Alien. Those Alien movies, right? Those are sci-fi. And so let's say SN. What's the vector for this one going to look like? So what's the vector for this one going to look like, you think? Which words? Car chases, there's no car chases, 0. Sci-fi, amazing things, yeah, sure. And so based on this, the algorithm learns, okay, whenever I see a 1 here and a 0 here, I can assume that I'm going to predict, which we're going to call Y-pred, right? The prediction will be what? Which class will it predict most likely, given this data set? Which one? -1 or 1?
-1.
-1, right? -1, which in this case would be like sci-fi. All right, so that's this concept here is really important, okay? If you only did words here, that's wrong. Okay, and that's why you lost some points there. I saw that actually in some of you. This needed to be something a little bit richer, sentences. Which, I'm imagining is because you had trouble, getting the sentences, but that's what you had to do. So what some of you did is they just used, that's why I gave you the RSS feeds, right? The RSS, if you looked at it, you could print out just, one RSS, one RSS, one RSS, and each one of those becomes a sample. But then I also asked you to create a data set of at least 100 samples, right? And then annotate it. Okay, and then the annotation, as I said, you'd only needed to do like a 2-class problem, although you could have had 3, 4, 5 classes. Okay? The words should not have been labeled. At any time, should the actual words have been labeled. I actually did see that, and that would not be correct. Why? Because in machine learning, you don't want to have, for supervised learning, too many classes, in fact. Having more than like 30 classes is, it's not something I would recommend. Okay? You want to have fewer than that. You've seen examples. There's the 2-class problem. There's 3-class problems like Iris. MNIST has 10 classes. Those things are fine. Okay? So that's basically it. So now, let's talk a little bit about the Twitter homework, which, as I said, I'm not assigning yet, but it's your second attempt at doing this better. And after that, I'm going to open it up for questions a little bit. All right, so Twitter. What do I want you to do in the Twitter homework? The code is already there. Okay, I've already provided it for you. Remember, Twitter is a company, and they make a lot of money out of selling the tweets to people. So they're not just going to give you all the tweets that you ask them for. In fact, I think they do what is called throttling. So they throttle you to about 100 tweets per day or something like that. So you won't be able to, so this homework assignment, you will need to collect data over a few days. Now, the code I already provided is there so that you just have to type or you can, you don't even have to use my code. I just provide that as reference. There's tons of other code that you can try, libraries, etc. But basically, the code provides, let's say you pick 3 topics, right? You're going to pick like machine learning, AI, Python, something like that. And so you search each one of those on Twitter, and then Twitter will return, let's say, 100 tweets, which by definition, a tweet, I think a tweet is spelled like that. So a tweet is what, like 130 characters, I think, the longest? Or 130 words, I believe. I'm not sure. But they're short. They're short. And so in this one, just make each tweet, just very much like I wanted you to do the RSS things, make each one of those a sample. All right, so you're going to take a tweet, and you can just use count vectorizer again. I'm not even going to ask you to do part 1 in this one. Just do part 2. Okay, but you need to show me your work, right? Again, I'm going to ask you to have at least 100 samples, and you need to label them. How do you label them or annotate them? That's going to be entirely up to you based on the problem that you want. Let's say that you have an interest in understanding, what are people saying on Twitter about, what are they saying about, let's pick a thing like a car. What are they saying about the newest, I don't know. Oh, the newest Tesla truck, let's say, that new Tesla truck, right? Well, okay, then go to Twitter and type Tesla truck, or I'm sure it has a specific name, model or something. And so say that. Keep it short, try to do keyword searches, not sentence searches. And then it'll return to you over a few days, because you have to collect data over a few days, some tweets. Once you have 100 tweets, read the tweets. You're going to have to read them manually, and then try to figure out a problem that you're trying to, address. You could also do multiple searches of multiple tweets, kind of combine them together. You could do tweets about, let's say you pick 5 medicines, 5 medicines, right? Whatever, headache medicines, whatever. You do the collection of those, collect the tweets, and then you try to figure out some problem. Are they saying positive things or negative things about these drugs? Are they saying, so for instance, maybe you want to do a problem where you say, I downloaded 100 tweets of 5 medicines, and now I want to find which one of these tweets people said they actually took it and it was good versus which one of these they took and they said it was bad, right? So you label it. So you have your data set, S1 all the way, S2 all the way to SN, where N is 100, right? 100 tweets. Each one of these is a tweet. You're gonna label them. You know, you can 0, 0, 1, 1, 1, right? 0, 1, 0, like that. And that just means, okay, I read this tweet and I thought, when I read it as a human, my impression is they were talking about medicine 4, whatever, it doesn't matter. And they were saying that the medicine they took was actually really good. They felt better. So you mark it as a 0. Then you find another one and they took the medicine, and when they made the conclusion, they said, you know what? I didn't like that medicine. It actually gave me, side effects. So I got side effects from it, and so that's not a good medicine to take. All right, and that's basically what the machine learning algorithm would train on. And that's the labels, right? That's the labels. But you still need to figure out the features. Now the features, you can do a lot of things to generate the features. For now, again, I'm just going to ask you to take the bag of words approach. The bag of words approach. And the bag of words approach, remember, what is it? It's just words. So instead of F1, F2, I can write W1, W2, W3, ... Wn. Does that make sense, guys? And then again, it's going to be the most, for this, you can use count vectorizer. You can use count vectorizer. And count vectorizer will, again, find the most frequent words. That's why I gave you that plot, right? So that you kind of got that idea that we were taking the most frequent words in the entire corpus. So you're going to give it 100 tweets. Or more. You can do more than that if you'd like. But, you know, I don't want to overwhelm you with that. I'm more interested in you doing this correctly. And once you have that, you're going to identify the top words, and then you're going to run count vectorizer on all the sentences. And if you remember from that lab that we did, I showed you guys how we could run the code and get the representation of the words, right? So then at that point you get, the most frequent N words, and that becomes the vector, the feature vector representation of each sentence, which again, it's going to be, 1, 0, 0, 1, 0, 0, 1, 1, 1, 0, 1, 1. It just depends on which word. And remember, it's actually a count, so this could be a 2. It's a representation of the word, the most common words in that sentence, the words that are appearing in that sentence. And that's it. Does that make sense? And then once you do that, you end up with a data set that looks like this. So you can just, convert it to a CSV. So a lot of these Pandas has a function called Pandas To CSV. Right, and it's going to take your data and just write out the text file. All right, and then from there, you have to load that into Weka. Now, from what I could see from your homework assignments, I didn't see anyone, most of you got that right. You created the text file. I mean, it's only 100 samples. You could literally just print it out on the screen, copy paste it into a text file too, as long as it's comma separated. So remember that Iris, doesn't really need to have a header, but it needs to have, like the value. So it'll be 1, 0, 0. Let's say it's got, you know, dot, 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 0, and then the last one can be the label. Right, so let's say here you would use, again, you know, 0, but it's now the label just for this column, or 1, 1, 0, 0. And you create this data set, and then the way to test this is now load it into Weka. Oops. Because right now we're just, you know, we're not so concerned with anything else, so just load it into Weka. And, oops. Load it into Weka. And if you can perform some machine learning, run a few algorithms, get some precision and recalls, great. Do a feature ranking. And that's it. So that was the initial homework. And that's really what I'm going to ask you to do with Twitter now, with the homework assignment. But as I said, I will assign that next Monday after the exam. All right. So I've gone over this. I don't know if I think it was clear, but if there's anything else that you're still not understanding or not clear, as I said, to me, this is very important. And one thing that I really want you to understand about, you know, in 520, this class, in the first half of the semester, is this, right? So, you know, I'm going to keep, you know, learn the terminology. Corpus, so kind of in summary here. Some of the terminology: corpus, features. You need to know exactly what those things mean because they're very important. Sample. Now, does a sample always have to be a sentence? No, it can be a tweet. It could be a paragraph. It could be a document. It could be a packet from a network. It could be an image. Could it be 3 images that are average? Sure. Could it be 100 packets in a second that are average? Sure. You know, it can be a lot of those things. It's very abstract, and that's why you first need to define what it is, but it always kind of translates into X and Y, right? So you can see labels. Labels go there. Samples. Samples are the rows. Features are the columns. And the corpus implies something that, the whole thing that is annotated, it has the labels and everything. All right, so, and everything is numbers, right? So everything here is numbers. I know that Weka allows strings here, but actually get away from that of putting, you know, like setosa, versicolor. You know, I know Weka allows that, but the other, everything else that we're going to be using for the rest of the semester does not. So in that case, you always want to change those into 0, 0, 1, 1, 2, 2, right? So the actual labels themselves. All right, so I've gone over this. I wanted to go over the homework because, you know, I believe it's really important. So now I'm going to open it up to questions to see if you guys have any questions about this, anything you don't understand or anything else. So questions. Remember, this is, you know, we have our exam next week, and I'm going to really stress this on the exam, okay? Because I feel it's very important. Are there any questions? Really, no questions? I thought you're gonna have like a lot of questions. All right, so I'm getting a question here for the labels. We assign randomly or just assign based on the feature? Okay, so neither, right? Labels should never be assigned randomly. Again, that, okay. So the idea with labels is the machine learning algorithm is going to learn how to analyze the data the way that you analyzed it. Okay. So again, I do, you know, the cat is sleeping. The dog is playing. The car is going fast. The boat sank. I'm not just gonna, if these are the labels for this example, I'm not just gonna, oh, well, you know, randomly. I'm not gonna do that, right? That's, why would a machine learning algorithm learn to do things randomly? You don't, you assign them not necessarily based on the words. I wouldn't say that. So comment was, or just assign based on the feature. So I wouldn't do that. Instead, I would say you assign based on two things. The labels are assigned, so labels are assigned based on the problem you are trying to solve. Based on the problem you are trying to solve. And the meaning of the sample. All right, so for instance, if I look at this and I say the cat is sleeping, the dog is playing, the car is going fast, the boat sank. Okay. How would you guys label these? How many classes? Let's say it's a 2-class problem. So 2 classes. What would you say could be the labels for this?
Vehicle versus animal.
Vehicle versus animal. Very good. Exactly. That's, you know, that's a good one, right? And you know, we're humans, so we have a way of thinking like that. So time, how so? Elaborate. How would you analyze this as time? Grammar. Okay. Maybe. The time idea is actually not a bad one. What somebody said is instead of animal and both, which we could do, if we did, so let's take both examples, 2 suggestions. The problem we want is to determine time, you know, tense, right? Tense. Versus the other one is, you know, type of object or living being or something like that. So in one scenario, annotation, we would say 0, 0, 1, 1, right? Cat, dog, the cat is sleeping, the dog is playing, the car is going fast, the boat sank. So these are, this is this one. But actually that was a good example, time tense, right? So if I do time tense, how would I label these? How would I label these 3 samples, given that I'm going to consider not this one, but now this one? What would they be? Zero, 0, 1, exactly. Present, past, future, exactly. So is, sank, right? So 0, 0, 0, 1. You see that? You label things based on what you want to do. So here we have two totally different machine learning algorithms. One with the same data but different labels. This one just tries to detect if it's kind of an object versus a living thing. Object, living, right? The other one is an interesting one. I want to actually find sentences in the present versus sentences in the past versus sentences in the future. So it's so, you know, the cat is sleeping, the dog is playing, the car is going fast, the boat sank. Now, this is an important thing also I want to say. You don't actually have, so that's what's so, and maybe this is something you haven't understood yet, but this is what makes machine learning such an amazing thing. You don't have to worry about how it does it. That's what machine learning means. The algorithms will figure it out. You as a person are intelligent, but it kind of goes back to this idea that sometimes we do things and we don't know how we did them. You're like, yeah, I did it, but you know, I don't even know how I did it. I just did it. You know, my brain was able to figure it out. And so it's the same here. You just read the sentence. The car is sleeping. The dog is playing. The car is going fast. Okay, you know that. You know, one class, the boat sank. That's another class. Now, how did you figure it out? You don't even have to worry about that. You just read the sentences, assign the labels. This is a very easy problem, so you can probably figure out that is and sank have something to do with it. But when you have really long sentences and much more complex problems, you will not be able to handcraft the rules, okay? Instead, you're just gonna rely on the machine learning algorithm to figure it out. You read the whole thing and you assign one of the 2-3 labels, your job is done, okay? And that's called, as I said, annotation, okay? Annotating the data set. There's a lot more that goes into annotation, but that's more of a, you know, if this was a natural language processing class, for instance, I would probably go into all those details. But, you know, for a machine learning class, this is as far as I'm going to take it. So does this make sense, guys? Does this make a little bit more sense? As far as annotation, it should not be random or based on the features. It's really the whole picture. Right? Look at the set. So when you do the tweets, just read the tweets based on the problem that you want to do. Which one? You know, like I said, I've given you examples. How do people feel about medicines? This is an example about tense in time, object versus living. And you can, there's a million of those that you can invent. And as you can see, the labels will change and therefore the algorithm changes. Here, notice that the features, I just left up the sentences. You still need to convert them. You would probably use the bag of words approach. Master this one. That's the first feature transformation that you have to master is the bag of words approach. Okay, you got to master that one. Feel comfortable with it. Once you feel, you know, you can, because believe me, it'll get more complicated than that. All right, good. Those were actually good questions and comments. Are there any other questions and comments about this? As I said, this is an important thing for your next exam, for the Twitter homework. I want to see that Twitter homework be done 100%. Okay, so I will certainly, you know, I graded very easy part 2 because I really just wanted you to try it and get. But the Twitter homework is really, think of it as your practical exam. Okay, so you'll have a written exam on Monday, as we said, and then the practical exam will be that lab, okay, of Twitter, getting the data and doing this completely right. And I want to see when you do the Weka part, I want to see some okay results. Okay, not great necessarily, but just some okay results. But if I see errors or misunderstandings, like, you know, like I said, like where your sentences are words, or, you know, I will know that you're still not grasping the concept. So, and this is a very important concept that you need to grasp. So I would argue even more important, you know, than understanding gradient descent or understanding, you know, cost functions and all that. That, you know, I'm not so worried about that because you can always just use Weka for instance, and do a little bit of machine learning. But this, there is no weka for this. This is something that you always have to do by hand. And you must understand this really well. Because that's your power. You know, if you're ever hired as a consultant, believe me, no one's going to say, oh, here's the IRIS data set. They're going to say, you know, I have all these databases and systems. Do some machine learning. You have to understand how to create a data set, which basically translates into creating a corpus of data that has all of these, right? All of these. Are there any other questions, guys? Are there any other questions? No questions, really? All right, I'm gonna call your names. Okay, let's see. Okay. So do you have questions about not the Twitter homework, which, like I said, it's similar to the previous homework, but do you have any questions about the homework that I just graded? Like why did you lose points here? Do you understand why? You know, what I was talking about? Usually I said like, you know, part 2, or sometimes I said BSM not done correctly, and it would be that you didn't do things like this. Okay, but are there any questions about anything? Because we're gonna move on, okay? And if you guys don't ask questions, I'm going to assume you understand everything. Okay, so how many ways can we clean the data scrape? You needed to clean the data, and remember, I said this. You needed to clean the data good enough that I didn't see this. If you look at that, what does that tell you about the site? Nothing, right? It's basically that you got this from an HTML web page. But this is bad cleaning, really bad. Good cleaning means you get rid of all these characters. And getting rid of all those characters, you know, I gave you some examples. You have to use regular expressions, a lot of replace, right? Eventually, when you start getting to have good cleaning, when you have, as I said, you know, you have Tesla, Musk, what is it, electric, you know, Model X, you know, something like that, which tells me, okay, this website was, just by looking at these words, I can tell, yeah, possibly Tesla website or some article about electric cars or, you know, Elon Musk, something like that. There's gotta, you know, the meaning has to jump out, okay? And that's why you do part 1, because that, you know, that's also what you want to do in your sentences, right? That's what you want to do in your sentences. So when you do, so for instance, if you download, you know, websites, HTML, and you actually use the entire website for each sample, which you could, that's going to be very big, but you do that. But if your features are dot, comma, HTML, you know, greater than symbol, if those are your features, you didn't do a good job, right? You didn't do a good job. You have to clean it first. And then once you clean it, the bag of words should be these words. These are your features in the bag of words approach. Even let's say you have an article. An article it's written well, right? It's got grammar and everything. So it's going to have a lot of the, her, you know, things like that. Even those words you can filter out because they don't really provide much meaning to you. I think I had that example actually of this one. Let's look at this slide. Of all these words, which one is the most meaningless for the problem? For either problem, whether we were trying to determine time tense or object versus living, what was the most meaningless word? The and is, right? Well, actually, is had value, not is. Is has had value. The meaning, not meaningful, meaningless, right? So it didn't have any contribute. Okay, let me rephrase it. The word that has the least contribution to the machine learning.
The.
The, exactly, the. You see that? Oops, I didn't want to do that. Exactly, the, right? The is the word that had no contribution. So it makes sense to just get rid of it. Usually in natural language processing, those words are called stop words. Okay, so stop words. So you probably saw that somewhere. So those are even those words you can filter out. But at the end of the day, what you want is just words that have the most meaning in them. Okay? So that's why I do two assignments. So we did this assignment. I didn't take off that many points. Make sure you understand this concept. I will ask this a lot on the exam. Twitter homework, next Monday, it'll be assigned. And I've already explained it. And that really will be kind of my focus on text. All right. Then in the next few, we will go back to Iris. I'll do some images, and then I will show you. Okay, I already posted on GitHub, as I said, a zip file with just a few images, and we're going to learn about that. You know, getting the images going and audio and lots of other things. When we do reinforcement learning, I'll show you how to get data from sensors. So if you had a self-driving car and all of that, so I'll explain that. I'll even show you if you wanted to buy like a little robot car and control it with reinforcement learning. I'll show you how to do that. But right now, we just have to focus on the text processing, okay? All right, so we have 2 minutes left before 3:20. We're gonna take a 10-minute break from 3:20 to 3:30. And then we will start our TensorFlow discussion. So now we are, if you don't, you know, ask questions, you know, if you're still, so let me put it this way. If you're still stuck in this concept, you really need to maybe see me during office hours or somehow, but please make sure that, you know, maybe even go back to the homework and redo it, okay? Redo the homework, part 2, make sure you do that correctly. Do the Twitter homework correctly. I will be looking at this, you know, that homework is just about this. So obviously you will lose a lot more points if you don't do it right, okay? Think of it as the second part of your exam. The practical exam will be that Twitter homework, and I'll give you a week for it. All right, so are there any other questions about this? Somebody wrote something. Nope. All right, so no questions. So that tells me that you guys are clear, hopefully. I guess I'll see you on the written exam and on the practical Twitter homework. All right, so that's the plan. So let's do this. Let's take our 10-minute break. I'm gonna close this so I can start generating this video, and then we'll come back, and then we will be ready now to start a new phase for the semester. I believe Mitch is going to talk a little bit about a fix that we have for Scholar, right? But all right, so I'll stop here and I'll see you guys in 10 minutes.